quick thing about TOC, for those of you who do not know, let me just go through it in 5 minutes what it is, right? TOC is basically at a macro level. Let's assume any operation, whether it is manufacturing. So if it is a manufacturing operation, let's say your operation is a very dumb operation. It's set up like this with these work centers or machines or departments. If you're doing critical chain, doesn't matter, right? These are departments and the work flows like this, and in the end you produce a finished product, right? This could be a supply chain, it could be a distribution, it could be a project, it could be manufacturing, it could be anything. It could be bank operation. So for that matter, anything. And let's say these are machines that produce at this rate. So machine E produces at 9 per hour, machine D produces at 10 per hour, 6 per hour, so on and so forth. So where is the constraint? What is the machine that is limiting the output of this system? C, right? It can produce only 6, right? Now, a lot of times what we do not know in the system is what is the limiting department, what is the limiting machine, what is the limiting area, or what is the system constraint. We do not know this. The knowledge of this particular, just this gives a lot of ease with which we can manage an organization. So let's say we know what is the constraint. How much can we produce? How much can this system produce? 6, right? The next step in TOC, this is the identify constraint. This is the first step. Step number 2 would be what? Any guesses? We need to make sure that machine 6 produces 6. So the next step is exploit the constraint. If machine C produces anything less than 6, guess what the system output would be? So it doesn't matter if we produce 10 here, 12 here. It doesn't matter if we optimize these places and spend our time and energy on every place else. But if we spend our time making sure this produces 6, it means the system will produce 6, otherwise the system is going to produce less than 6. So the step number 2 in TOC is exploit the constraint. So how do we exploit it, right? By ensuring this machine doesn't break down. If this machine breaks down, guess what will happen? It will produce less than 6. Right? What happens if some other machine breaks down? There's some buffer available, right? It won't impact the system output. So you can start thinking about it, and sometimes it's not clear in your environment, in the department that you work. What is the constraint? If you draw a line, in your system, draw a line and say, this is what my system is. What is limiting the output of your system? Whatever you are producing, that is one way to approach it. Now, what happens if machine C produces? So look at the demand now. Now this is where you start to link it with the reality. It is a widget. It doesn't produce the widget every day. Let's say the demand is 24 red and 24 blue, right? What should this work on? It should work to produce 24 red and 24 blue. What if this produces 30 red? It's a waste. Your constraint is working on something. It's a precious resource. When it produces, you make money. It is working on something that is not useful to you. So if the constraint works on something that is not useful to you, it is a waste. So that is another way to think about from exploitation perspective, right? If you were to put in a quality control process, where would you put it? Where would you put it? I know you know it, but somebody else.
Before and after C. And see what C is doing.
So if you put it after C, what will happen? The C may rework, right? Because stuff will go through C and then you will find out something wrong with it. You may have to rework. That means you need more capacity for C. Your capacity for C is only 6. What would that mean? That means you will produce less than 6. So this knowledge, where the constraint is extremely powerful to run your organization. We would rather have a constraint than have no constraints. It's actually a good thing to have a constraint because now you know what is limiting your organization, right? If you don't know, then what are we trying to do? Everybody is trying to look good and trying to optimize. And in that case, this is trying to produce 9, this is trying to produce 10. There is overproduction in the system. And when there is overproduction in the system, the WIP goes higher and higher, and what are we doing? There's a lot of desynchronization, there's a lot of multitasking, and people are working on priorities that doesn't make sense to them. And this happens in a lot of big organizations, right? Small organization, it's easy to synchronize. Does it make sense what I'm saying? Now, what else would you do to make sure that C is protected for producing 6? What else would you do?
To build a backup.
Sorry?
To build a backup.
You build something here, some protection for C, because we know when we come to office there is some uncertainty every day. There is something that will go wrong, right? Everything can't be perfect. Machines will break down, or people will not show up to work, skills will be different. There is an expert and there is another guy who's probably a new guy, not an expert. So what will happen is that we will have to create a buffer in order to protect. So what if D broke down? What if E broke down? And they broke down for a much longer period. In order to provide stability to the system, you will have to maintain a buffer here, not anywhere else. It's a very specific thing, right? So if we have a buffer here, then even if these machines broke down to a certain extent, your operation is still stable. You're not impacted by it. Any other thing that you think about from exploitation perspective for C? We do it naturally, these things, but we don't think about it like this in a sequence, right?
If you build a buffer from an accounting standpoint, that'll be an overhead, right?
Absolutely. All of these things are counter to the traditional cost accounting perspective. They are really counterintuitive. Because if you think about it, have I brought accounting anywhere? No. In the current mode, the accounting is focused on how much do you produce as E. Are you busy or not? Are you producing? I hired 3 heads. Show me that I can show production out for 3 heads in this department. But here we are not talking about this. We are talking about how can I make money. When this produces, it makes money. When this produces 9, it doesn't make money. It gets stuck somewhere in the system. It's an inventory. Right? So it's a throughput thinking than just cost thinking.
You can retrain everybody on C and operate through balance.
And I will come to that, for sure.
Equivalent.
One other thing that we realize, like a lot of times when we go there and we find that simple example if you're expert in your environment, in IT environment, you're developing, some guy is really crucial has the knowledge, but he's doing non-value added work, right? He's doing all the work which somebody else can do. Then offload that work. Why is he doing accounting? Why is he doing spreadsheets? Why is he take all that work from that expert and make sure the person is working on the stuff that really makes sense. So if you offload work from that person, then maybe you are bringing in more 6 per hour or more, right? So offloading stuff, offloading non-value added stuff is another way to exploit. So these are all the exploitation steps. Is this sufficient? No, there is one more step to make sure. So we talked about what is constraint, and we talked about how to exploit the constraint. The third thing is, how does the whole organization work to this knowledge that there is a constraint? Which means that how should E behave now? Because there is still not, it's not very clear how rest of the organizations will work, knowing that there is a constraint here, right? So what this is about is that the purpose of E, because one thing, let's go back, right? One thing we know, when C works, it makes money for the system. So when should E work? E should work only to replenish C. So which means one out, one in. That's the sole purpose, to feed C. Continue to feed C. Because when C works, you make money. Does it make sense? We don't set up these things like this. Unfortunately, wherever we have gone and implemented, they only change it when they get into trouble. When the profitability is not there, or when the company is like tanking and not making money, there's huge amount of cost pressure, then they are willing to change. It's like, okay, fine, we can do all these steps. But regular operation is all about, let's optimize this, let's optimize this. Everybody is optimizing and creating a huge amount of work in the system. And there's a lot of inventory. There's a lot of inventory in the system. And if you really talk about the inventory in real sense, go to all these retail stores and really there's a lot of inventory. I mean, they're not able to sell, they go out of business. So this is what subordination means. Which means that how will E work? How will D work? They will work when this is depleting. So if you deplete one because you are trying to maintain some amount of buffer here, if this depletes by one, you produce one. That's the sole role. For the downstream here in this case, the sole role of B and A is when you get work, finish it. So we are not measuring them to local productivity. Now, when you continue to operate like this and you find out, okay, 9 is too much, I can optimize it slightly. So I can now start to balance the line. But before that, you can't. Let me ask you one question, and then we will this will complete what DOC is. What if you were to ask from cost accounting perspective, why not this, all of them are 6 per hour, 6 per hour, 6 per hour, 6 per hour? What's harm in that? Sorry?
The system will never produce 6 per hour because of the fluctuation.
Yes. Right? There is a fluctuation here, which means you are trying to protect 6 per hour, you need some buffer here. That will naturally how people will think, right? This is how it will manifest. There is 6 per hour requirement here. They will try to protect themselves for 6 hours, they will maintain some buffer here. So in order to produce 6 per hour everywhere, you need to have so much buffer in the system that it becomes infeasible. The profitability is different. So the only way it can is not to balance to 6 per hour, but to maintain buffer here and have a slightly extra capacity. This is step number 3. So exploit the constraint. So identify the constraint, exploit the constraint, subordinate to that decision about the constraint. Now at some point, if your market goes much bigger and you need to really produce much more than 6, then you really need an investment. Because the constraints are not like this, hey, I call developer as constraint because I'm not going to hire. No, it's difficult to elevate, it's difficult to hire more people like that. It's difficult to have those kind of experts. That's why they are constrained. Now, if you get more and if you decide to elevate and make a big investment, then what will happen? If you make an investment, you're not going to increase 6 by 1 and make it 7. You will probably make a good amount of investment. So when this goes to 8 or 9, guess what happens? So elevation means you have now elevated it, put in big investment into it. Your constraints move. It moved to A now. If this became 10, for example, because of the investment, this is your elevation step, then your new constraint is A. You have to set up the entire organization to the tune of the new constraint. It is disruptive. All those decisions will have to be taken again. So you would rather want to identify a constraint and you want to run a very stable operation with, put the constraint there and keep it there for some time to operate in a stable way and make a lot of money. And then when you decide to move it, you move it, but then you have to go through all these steps again. So the final step here is really don't let the inertia become the constraint. Basically go and identify the new constraint and then set up the whole system. Now you can apply these 5 principles to any area of operations, whether it is projects, whether it is manufacturing, whether it is supply chain, whether it is retail, any area of operation. One of the cool